Today we will be discussing about how to convert your decimal numbers to octal number system. So we'll be doing this one to octal. We know that this one becomes base 10 to become base 8. Okay, so we know that base 10 has a number system from 0 to 9. So including 0, that is 10 numbers. And base 8 is 0 to 7. So including 0, that is 8 numbers in total. So we proceed with 49 base 10 to the octal number system. It is the same as we do in our binary, so decimal to binary. It is the same method to successively divide the number in its radix and get the remainders and read it backward. For 49, since this is octal, so it should be divided by this one to 8. We know that 6 is the nearest to 49. We can get a 48 and then you have a remainder 1. So take note of that. And then let's divide 6 to 8 again. This time you'll be getting 0 and then 0 times 8 is 0. That's why you have a remainder of 6. And then this is the significant one, the least significant, and this one is the most significant. So you read it backward. So you can say that 49 base 10 in decimal is equal to 61 base 8. So that is your answer. How about number 2? A numbers a number or a decimal number with a fraction part. Same that we are doing in binary, so you separate the fraction part and you separate the integer part. So number 2, let's erase this one. Number 2, 55.72 base 10 to octal. Okay, so you need to separate the integer part and the fraction part. So we do for the integer part the same as we did on number 1. So divide it by 8. The nearest would be how much? That is 6 by 8 is 48. If we try 8 by 7, how much did you get? 8 by 7, you will be getting a 56. So the possible would be just 8 by 6. Okay, so this is 48. And what becomes the remainder is 55 minus 48 is 7. Then, okay, so that is the remainder. And then we have 6 divided by 8, that is 0. And then that is 0, that is 6. Okay, so least significant, most significant, read it backwards. So you get 67 for this. So that is not yet the answer because we have the fraction part. So for fraction part, just times the fraction part to the radix of the number system you are converting to. So this time it is octal, so that is 0.72 times 8. So that yields us as 0.72 times 8 is equals to 5.76. Okay. So take note of the integer part resulting from this process because this is now your octal digit. Okay, okay, and then so just maintain that octal digit, then disregard ins, uh, uh, getting more of the fraction part of this one. So you just leave 5 and then bring down the 0.76. Okay, then 8, and then you'll be getting 0.76 times 8 is equals to 6.08. Okay, and then you have 6 now. And then 0 point, the fraction part only is 0.08 times 8 is equals to 0.64. And then fraction part, 0.64 times 8 is 5.12. So this will not be become 0, but it will be composed of so many digits. So you can actually stop here, or if your instructor asked you to stop at 4 decimal places only. Okay, so you read this one. So you have a number of 0.5605 at base 8 now. So that's the one how you read it. So to combine it with 67, you can write that is 67.05. I mean 67.5605 base 8 is equivalent to the 55.72 in base 10. So that should be your answer. Okay. That's all for the conversion of decimal to octal.